NENOMATICA, where mathematics meets YouTube excellence. Exponential equations. Welcome to this math tutorial. Today we're going to learn about exponential equations and how to solve them. An exponential equation is an equation where the variable appears in the exponent, like the example we're going to solve today. Let's look at our example. To solve this type of exponential equation, we need to convert both sides to have the same base. Then we can equate the exponents. We notice that 16 can be rewritten as 2 to the power of 4, since 2 to the fourth is 16. Now that both sides have the same base, we can set the exponents equal to each other. When we have the same base on both sides of an equation, the exponents must be equal. Let's verify our solution by substituting x equals 4 back into the original equation. Important note: to solve exponential equations, you need to have a good understanding of the definitions, rules, and properties of exponents. Let's look at another example to reinforce our understanding. In this case, we recognize that 27 can be written as 3 to the power of 3, since 3 cubed is 27. Again, since both sides have the same base, we can set the exponents equal to each other. In general, to solve exponential equations where the bases are different, we often convert to the same base or use logarithms. Let's summarize the main approach we use today. And that's how we solve basic exponential equations. Remember, the key is getting both sides to the same base, so we can apply the property that if the bases are equal, the exponents must also be equal. Thank you for watching. Let's look at some examples and solve them step by step. Let's start with our first example. First, we'll look at the right side of our equation. We need to express 256 as a power of 4, since our base on the left side is 4. Now that we have the same base on both sides of the equation, we can set the exponents equal to each other. This is a fundamental property of exponential equations. Finally, we solve for x by dividing both sides by 2. Let's move on to our second example. Here's our second example. For this problem, we'll start by rewriting 8 as a power of 2. 8 equals 2 to the third power. Next, we'll use the power of a power rule to simplify the left side. Now we'll distribute 3 into the parentheses. Now we need to express 512 as a power of 2. Since the bases are now the same, we can set the exponents equal to each other. Now we solve for x. Add 3 to both sides. Finally, dividing both sides by 3, we get x equals 4. Let's solve another example. Here's our third example. For this problem, we need to recall that any number raised to the power of 0 equals 1. Since the bases are the same, we can set the exponents equal to each other. So x equals 3 is our solution. We need to solve the exponential equation 9 to the power of x plus 1 equals 27 times 3 to the power of x plus 2. To solve this equation, we'll first convert everything to the same base. Let's start by recognizing that 9 is 3 squared and 27 is 3 cubed. Now, let's express 9 to the power of x as 3 to the power of 2x and 9 as 3 squared. Now, let's combine the exponents on each side using the product rule of exponents. When we have expressions with the same base raised to different powers, the exponents must be equal for the expressions to be equal. Now we can solve this linear equation. Let's move all terms with x to the left side and constants to the right. Simplifying both sides, we get x equals 3. Let's look at another example. This one is in Persian, but we'll solve it in English. The equation is 2 to the power of 2x equals 4 to the power of 50. For this equation, we need to rewrite 4 to the power of 50 using a base of 2. Since 4 equals 2 squared, we can rewrite this. Next, we use the power of a power rule to simplify the right side of our equation. Since both sides have the same base, we can equate the exponents. Solving for x, we divide both sides by 2. Let's summarize the key strategies for solving exponential equations. First, convert all terms to the same base. Then, use exponent properties to simplify both sides. Finally, equate the exponents and solve the resulting equation. This approach works for many types of exponential equations. We need to solve 7 raised to the power of x plus 1 minus 7 equals 42. To solve this equation, we'll first add 7 to both sides to isolate the exponential term. Now, we can simplify the equation. On the left side, negative 7 plus 7 equals 0. And on the right side, 42 plus 7 equals 49. Now, we notice that 49 is equal to 7 squared. This gives us a key insight for solving the equation. When we have equal bases with exponents, we can equate the exponents. So, x plus 1 equals 2. Finally, we can solve for x by subtracting 1 from both sides. This gives us x equals 1, which is our solution. Let's solve the following exponential equation. The left-hand side has a fraction with 1/2 raised to the power of 2 minus x, and the right-hand side is 4 to the power of negative 75. Let's start by rewriting the left side of the equation. We can rewrite this fraction as 2 to the power of x minus 2. This is because 1/2 is equal to 2 raised to the power of negative 1. So 1/2 raised to the power of 2 minus x is the same as 2 to the power of negative 1 times 2 minus x, which simplifies to 2 to the power of x minus 2. Next, we'll rewrite the right side of the equation. Since 4 is equal to 2 squared, we can rewrite 4 to the power of 75 as 2 squared to the power of 75, which is equal to 2 to the power of 150. Now both sides of the equation have the same base, which is 2. When you have an equation with the same base on both sides, you can set the exponents equal to each other. This is because if 2 to the power of a equals 2 to the power of b, then a must equal b. Therefore, we can set the exponents equal and say that x minus 2 equals 150. This gives us a simple linear equation to solve. The final step is to solve for x by adding 2 to both sides. We get x equals 152, which is our answer. We have 3 to the power of 2x minus 3 equals 81. First, I'll rewrite 81 as a power of 3. Since 81 equals 3 to the 4th power, I can write this as 3 to the power of 2x minus 3 equals 3 to the 4th power. When we have the same base on both sides of an equation, we can equate the exponents. So 2x minus 3 equals 4. Now I'll solve for 2x by adding 3 to both sides. 2x equals 7. Finally, I'll divide both sides by 2 to solve for x. This gives us x equals 7 over 2, or 3.5. Let's solve another exponential equation. 5 to the power of 3x equals 5 to the power of 7x minus 2. Since we have the same base on both sides, which is 5, we can equate the exponents directly. Next, I'll move all terms with x to the left side of the equation. Subtracting 7x from both sides, I get negative 4x equals negative 2. Finally, I'll divide both sides by negative 4 to solve for x. This gives us x equals 1/2. We need to solve the equation 3 raised to the power z equals 9 raised to the power z plus 5. Our first step is to rewrite the base on the right side. Since 9 equals 3 squared, we can rewrite 9 raised to the power z plus 5 as 3 squared raised to the power z plus 5. Now we can apply the power of a power rule, which states that when we have a power raised to another power, we multiply the exponents. So 3 squared raised to the power of z plus 5 becomes 3 raised to the power of 2 times the quantity z plus 5. Since we now have the same base on both sides, the exponents must be equal. This allows us to set up the equation z equals 2 times z plus 5. Let's expand the right side of the equation. 2 times z plus 5 equals 2z plus 10. Now we can solve for z by subtracting 2z from both sides. This gives us negative z equals 10, or z equals negative 10. Let's verify our solution by substituting z equals negative 10 into the original equation. On the left side, we get 3 raised to the power negative 10. On the right side, we get 9 raised to the power negative 10 plus 5, which is 9 raised to the power negative 5. Let's check if these are equal. Now, let's solve our second example. We have 4 raised to the power 5 minus 9, x equals 1 divided by 8 raised to the power x minus 2. Our first step is to rewrite both bases as powers of 2. Since 4 equals 2 squared and 8 equals 2 cubed, we can rewrite the equation as 2 squared raised to the power 5 minus 9, x equals 1 divided by 2 cubed raised to the power x minus 2. Next, we'll apply the power of a power rule to simplify the exponents. This gives us 2 raised to the power 2 times 5 minus 9, x equals 1 divided by 2 raised to the power 3 times x minus 2. Let's multiply the exponents. On the left, we get 2 raised to the power 10 minus 18x. On the right, we get 1 divided by 2 raised to the power 3x minus 6. Now, we can rewrite the right side using the negative exponent rule. 1 divided by 2 raised to the power 3x minus 6 equals 2 raised to the power negative 3x plus 6. Simplifying the exponent on the right side, negative 3x plus 6 equals negative 3x plus 6. Since we have the same base on both sides, we can set the exponents equal. This gives us 10 minus 18x equals negative 3x plus 6. Now we can solve for x by rearranging the equation. Let's first subtract 10 from both sides. This gives us negative 18x equals negative 3x minus 4. Next, let's add 3x to both sides. This gives us negative 15x equals negative 4. Finally, we divide both sides by negative 15 to get x equals 4/15. Let's solve exponential equations. Today, we'll solve the equation 10 raised to the power of t squared minus t equals 100. The first step is to rewrite 100 as 10 squared. This gives us 10 raised to the power of t squared minus t equals 10 squared. When we have the same base on both sides of the equation, we can set the exponents equal. This is a key property of exponential equations. If a raised to the power of m equals a raised to the power of n, then m equals n. So we get t squared minus t equals 2. Next, we rearrange the equation to the standard form of a quadratic equation, which gives us t squared minus t minus 2 equals 0. Now we can factorize this quadratic equation. We get t minus 2 times t plus 1 equals 0. Finally, we find the values of t by setting each factor equal to 0. Either t minus 2 equals 0, which gives us t equals 2, or t plus 1 equals 0, which gives us t equals negative 1. So our solution set is t equals 2 or t equals negative 1. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.